So let me start. I will share my screen. So as some part of participants doesn't have experience with bathymetry, I will briefly touch theory from the beginning. What is bathymetry? Bathymetry is the process of measurement of the depth of water, any water, in ponds, lakes, river, oceans, seas, any water bodies. Very interesting that standard result of bathymetry is not the depth data, but elevation data for the bottom. Because depth, it is not something constant, it varies in quite wide extents because of tides. Technological ponds can be emptied, filled, but bottom elevation is more constant and typical more common results of bathymetry. It's the data for the bottom elevation. Technology, bathymetry exists for the centuries, but kind of modern technology, most popular technology for bathymetry was developed more than 100 years ago. In 1920s, Dr. Herbert Dorsey introduced echosounder, device which sends sound impulses down to the bottom and measures the time required for the sound to travel to the bottom and to travel back. But our very innovative system uses technology developed more than 100 years ago. Funny fact. So how, bit more details how it works. So device called transducer emits sound impulse in the direction to the bottom, straight down. And after some time, it will receive the echo, reflected sound from the bottom. We can measure the time required for the sound to travel down to the bottom and back. And as we know sound speed in the water, we can easily calculate the depth. Interesting that sound speed in the water is not constant. It varies depending on temperature, salinity of the water, but it will be more or less around 1,500 meters per second. If you need very precise measurements, you can use special devices called sound velocity profilers, which can be dropped down to the water and measure the sound speed according to the water column at the different depth. But principle, and data from such device, sound velocity profiler, can be used when you process echosounder data. But principle is the same, very simple. Emit the sound, measure the time, and recalculate time to the depth. Very simple. Of course, modern echosounders are not the same as 100 years ago. They are modern echosounders, especially for the limited depth. Limited depth, I mean, up to a couple of hundreds of meters can be very small, and maybe smallest echosounders on the market are manufactured by Echologger, by company of Duon. And second big change in technology is digital signal processing. So in 100 years ago, echosounder, all the system had many bulky components, transducer, which emits and after that receives the sound, and also kind of big machine, analog machine, to recalculate time to the depth. And now everything is inside of echosounder. It has a digital interface and outputs depth measurements, ready to use depth measurements. So what current tools exist on the market which can be used for the bathymetry for depth measurements or for the bottom profiling? Still very popular method, and maybe it's the cheapest method, using measurement pole or simple measurement pole or measurement pole with RTK receiver on top of it. That method cheap. It works perfectly for the more or less safe environment and in case, of course, of not very deep water. Single beam echo sounders, it is what we are discussing today. Most oldest proven and robust technology. It measures the depth in the single point at time. Multi-beam echo sounder systems, more modern technology. It is kind of aerial LiDAR, scanning LiDAR, but it scans bottom in the direction of perpendicular to the line of survey. So big benefit of multi-beam system that it provides much better data density for the bottom elevation or for the depth. And it can greatly decrease survey time required to cover the same area with required data density or bathymetric coverage. We are working on multi-beam echo sounder systems. Maybe you saw my posts in LinkedIn, but single beam is still the only product which we have ready to supply, ready to deliver for our customers. And it will stay forever because single beam echo sounder systems are much more simple to operate, and in general they have better accuracy, better precision, and big benefit that using dual frequency single beam echo sounder systems, we can penetrate sediments sometime. So we can measure not just the bottom, but also measure the depth till the sediments and till the hard bottom. Next technology is green LiDAR. It's a technology what was developed for airborne use. It's a variety or modification of scanning LiDARs. Great technology. Main benefit that it has extremely high productivity, and in single pass you can scan bottom and scan land which is not under the water. It's a great benefit, great productivity, but it has two main drawbacks. First, extremely high cost of the sensor. So price of 100,000 euros or dollars is for entry-level systems. And also it has a very limited depth. So effectively, for example, in Latvia, green LiDARs cannot be used for almost all inland waters because their water here is not very transparent. But again, great technology. And last, what I want to mention, it's a satellite-derived bathymetry. Also great technology, allows to estimate depth or elevation of the bottom for the thousands of square kilometers. But its accuracy is very low, and actually because of very low accuracy, data from it can be used for very limited scenarios. And also, of course, it doesn't work for the most of inland water because it has a low resolution and water is not transparent. So two flagship technologies actually are single beam and multi-beam echo sounder systems. We will discuss today single beam systems. Typical application scenarios for bathymetry, not only for drone-borne, but also in bathymetry of small-scale bathymetry, let me say, are dredging, planning, and monitoring. Data gathering for the construction planning. When you need to build something in the water or you have a water inside of your construction site, you need to know that. So it's very popular scenario. In mining industry, tailing storage facilities or open pit lakes should be monitored almost constantly for the capacity, for the volume of water or volume of sediments build up. Specific for the drone-borne applications is bathymetry in storages of aggressive liquids, where you cannot have access to the water body, to the liquid. It can be not a water, it can be some aggressive solvent, but drone-borne system, when you put just one sensor to the water, can be a solution for such scenario. And we have cases when our systems were used for the bottom profiling of the open air storages of dissolved acids. Environmental applications, river cross-sections profiling, and post-flood monitoring, post-flood mapping are also pretty common scenarios for our systems. Also very interesting, here on the screenshot, you can see bathymetric data of lake combined with the data from aerial LiDAR. So if you want to build 3D model of everything what is under the water and above the water, you can easily combine LiDAR data or photogrammetry data with data from gathered using single beam, multi-beam, of course, systems. It's a very simple and straightforward process. So, what is inside of our standard systems? What are standard components of our systems? Echo sounder suspended under the drone using cable. Onboard computer, it is small brick here mounted on the leg of the drone. Onboard computer we need to log the data coming from the sensor, from Echo sounder, and also for DJI drones we implemented what we called true terrain following, capability to have predefined precise altitude over the water in case of bathymetric surveys. To implement that, we use laser or radar altimeter. It is here. Here is radar altimeter. And we use software, our software for the mission planning, for the mission monitoring, and also actually a lot of software inside which run inside of our SkyHub onboard computer. Again, to log data and to manage the flight. And as part of package, we provide data processing software, because data from sensor, it is not kind of photos, it should be processing using purpose-built software. So we found pretty affordable and quite simple to use options for customers. Very typical question. Why we need a drone? Or guys, you are crazy. There are a lot of good unmanned surface vehicles or manned boats for the same purpose. For what can be used drone-borne sensor? For quite specific scenarios. First scenario is limited access to the water body. For example, you physically cannot deploy a boat because of steep cost or access to the water or to the liquid restricted for the safety reasons. So for drone-borne system, you should not be even close to the water body. We have cases when, from our customers, when takeoff landing position of the drone was in the hundreds of meters from the surveyed ponds. Second is mobilization cost. If you need to survey small ponds or small lakes, and you will bill for the customer for one survey, mobilization time is your money actually, it's your costs. So here, no one alternative method can compete with compact and transportable system using UAV, using drone. And also different scenarios with hazardous environment. When you should not be in survey area, you should not be close to the water. That's the main scenarios. If you have a boat, if you have access to the boat. You can rent it. You have quite good access to the water. You can easily deploy and recover boat. Your survey area is big. Maybe it's scenario not for drone-borne system. Yeah, and one more benefit. If you will compare survey results with manned, unmanned boats and drone-borne systems, usually we have much better precision of following of the survey lines. So for drones, plus minus few dozens of centimeters is normal. For unmanned boats, plus minus couple of meters is also normal. It doesn't have too big big difference for many scenarios, but if you need to repeat surveys with high precision, drone board system will work better. So what we have in our portfolio, we propose 3 models. Echologger company has more echo sounders in their portfolio, but we selected 3 models, which we propose as standard configurations. Single frequency device with frequency 150 kilohertz, dual frequency 200 and 450 kilohertz, and last one 50 and 200 kilohertz. What is dual frequency echo sounder? Technically, it's two echo sounders with different acoustic frequency combined in the same casing. So they do measurements using high frequency. Next pink will be using low frequency. I will explain the benefits of every system. So they have a different maximum depth, but 100 meters, it's more than enough for all typical applications of our systems. Actually, deepest data collected using our system was around 80 meters. One model can be used for the sediments measurements. All models have a tilt roll sensors, which is very important for drone-borne applications because sensor is suspended under the drone using cable. Actually, I have a sensor on my table. I will show it 1 second. It's a new model of D052. And it doesn't have hard mounting. So it is not extremely stable in the water. So we need to monitor actual orientation of the sensor for every measurement. And here tilt sensors are extremely important. We can correct measurements and we also can reject the data readings when sensor is far from vertical orientation. Also, inside of sensors, inside of echo sounders, we have temperature sensor. It is most easy way to make corrections for the sound velocity if we don't have sound velocity profiler. You can easily find in internet reference tables with the sound velocity depending on the temperature for freshwater and for the seawater. And here is the data for the weight of full sensor assemblies. What I mean full sensor assembly, it's a sensor, cable, and all the stuff required to attach sensor to the drone, to the drone. Full system of the kit is approximately 6 grams more because that number 1.3 kilograms or 1.9 kilograms, it is without onboard computer, altimeter, cables on the drone. So it is weight of sensor. What is the purpose of different sensors with different frequencies? Single beam echo sounder, single frequency echo sounder with frequency 450 kilohertz has a best resolution. It is not very expensive sensor, but when we use it in real life, sound with such high frequency will be reflected even from the vegetation on the bottom. So if we will profile bottom like here, we will get readings like something like a red line. In most cases, we don't need a depth till the civets, right? Till the vegetation, we need to measure the depth till the bottom. So in scenarios when we have a kind of heavy vegetation on the bottom, single frequency echo sounder may be not the best choice. So for that scenario, we would recommend next model, dual frequency echo sounder with frequencies 450, the same, and 200 kilohertz. Here, with the frequency 200 kilohertz, sound will, in most cases, penetrate through the vegetation at the bottom, and we will get reflection from the top layer of the bottom. So our data will be much more clean and will require much less effort for the processing. And last model is 250 kilohertz echo sounder. In some cases, 50 kilohertz sound with the frequency 50 kilohertz will penetrate through the sediments, covering the hard bottom. And we will have two data readings or plots. One is reflection, green line, from the top layer of the bottom, and second data set, second plot we will get from the hard bottom. It is extremely useful because in many cases, purpose of survey is exactly to estimate amount of sediments. For example, when we monitor sediments built up in the ponds. But it doesn't work in 100% cases. It works great in case of light organic sediments, but in case of mineral sediments, 50 kilohertz sound may not penetrate through the mineral sediments till the hard bottom. So that technology doesn't work in all cases. So it depends. In such situations, when you need to monitor sediments build up in ponds, for example, most robust method actually it's repeatable surveys. You can do one survey when pond was cleaned, you will have baseline, and after that you can do repeatable surveys and compare the data. Hydrometric data processing software, and I think almost all data processing packages allows to compare data sets to calculate difference in the volume between data sets. But in many cases, that dual frequency echo sounder will work, providing the data for top layer and for hard bottom. So let's discuss new models. New models. Here, we started to supply echo sounder systems, as I remember, starting from 2020. And initially, and for a few years, actually till the current year, we provided standard Echologger models designed for manned and unmanned bots without absolutely any modifications. Here is a photo of standard Echologger SCT-400 or similar model. It has acetal casing, quite light casing. As I remember, in the water, it has a positive buoyancy. And to use it, suspended under the drone, we, at SPH Engineering, add heavy housing made of stainless steel and added suspension system to attach it to the drone. Actually, little bit of history. I found in my house very first echo sounder, which I made in 2018 in basement of my house. It will go to our corporate museum. but our serial models were more or less the same. Standard echo sounder, stainless steel casing, and suspension system. But for the long time, it was absolutely standard demand to increase survey speed for our system, because you know that echo sounder, to make measurements, should be submerged to the water. And to make continuous measurements, we need to tow or drag echo sounder in the water. Unfortunately, drag is proportional to the second power of the speed. As I remember, second. Okay, doesn't matter. So if we will fly with higher speed, echo sounder will be very far from vertical orientation, and it will be not return the false readings. It will be not as stable in the water if you will drag it with high speed. So together with Echologger, we designed new line of sensors, especially for airborne use. Of course, they can be used for the unmanned and manned boats as well. What is main difference? Instead of acetal casing, echo sounder itself has stainless steel casing. That means we have the same weight. To have a stable sensor, we need to have quite heavy sensor when it is submerged to the water. But excluding plastic, with the same weight, we have much less size of the sensor. Smaller size means less drag in the water. Another benefit for us, especially for SPH engineering, that we are getting almost ready to use echo sounder right from the factory in Korea, from Echologger. The only small item what we need to add is a ring for the cable. All other now we are getting from factory. So I can show you again newest model. It's a D052 dual frequency echo sounder. So yeah, here is one more element, additional weight, but all other echo sounder, stainless steel echo sounder in stainless steel casing, additional housing, cable with protector, everything is we are getting from the factory, adding just this one small ring. Thanks to the smaller size of the sensor, we were able to design what we called high-speed option, high-speed add-on. What is high-speed add-on technically? This one. It's a fairing. It uses magnetic clamps. I hope it is visible. To install it on echo sounder, you need just to put echo sounder cable with the ring here. Put echo sounder and close. So installation time for the standard echo sounder is just 10 seconds. What we get here with that simple device is twice higher speed on survey lines with the same data quality. I also have a lot of museum exponents here. It was not easy task to design that pairing. Here are dozens of variants which we modeled and so on. That process took more than 1 year, and it costs us dozens of thousands of dollars for the computational fluid dynamic simulations, for the real tests. And now we have variant which we can supply for our customers. Very simple model. You still can use single beam echo sounders with that high speed add-on or fairing. In some situations. For example, in case of surveys in surf zones, in such situations that assembly with echo sounder may be not stable in rough waves. And if you need to use grasshopper mode. Grasshopper mode, it is when we do not continuous measurements dragging sensor in the water, but we make measurements in the points when drone is flying between measurement points, pulling out sensor from the water. So you still can use standard configuration and you can use the same system with high-speed fairing. How we tested the system? We did a lot of repeatable surveys. I hope, is Hydromagic visible?
Yes.
Yes, cool. So here is lake quite close to our office when we usually test our systems related to the water. So we did a lot of repeatable surveys using different configurations, using different speeds. And for all surveys, we used check lines, survey line which is perpendicular to a couple of regular survey lines. And we calculate difference in between check lines and the perpendicular lines, estimating accuracy of every configuration. We can do that by our eyes, just comparing the numbers, but also we can utilize a very useful function in processing software called cross-section statistics. So here we can select soundings or data sets what we want to analyze. For example, this one. Select what we will analyze, elevation for the low frequency, for example, and we can see the difference between lines in the same point. So what we have as result of our latest experiments, at the speed up to 1.6 meters per second, we have more or less the same accuracy of the data as with our benchmark. Benchmark is our standard configuration without fairing, without high speed add-on, at the low speed, 0.8 meters per second. With the speed higher than 1.6 meters per second, we have a bigger difference with benchmark. So currently, it is why currently we would recommend approximately 1.5 meters per second as a maximum speed. But you can do survey on the higher speed, for example, 2 meters per second, if accuracy around will be 3% of the depth is good for your survey. But with the speed up to 1.5, 1.6 meters per second, quality of the data will be the same as at the low speed without high speed add-on. That's all maybe about that option, and a couple of words about data processing. Data from echo sounder came in pretty simple but not ready for use, ready for interpretation format. It can be such files which looks as a cryptic, but it is standard, industry standard format for the bathymetric data. called NMEA. We also save data in CSV format. But anyway, if you want to get some report, you need to use purpose-built software. What usually customers expect as results of bathymetric surveys, they may expect depth maps or bottom elevation maps with the contour maps. They may expect cross-section profiles. They may expect just cleaned data to be used in the third-party software packages. They may expect point clouds to combine bathymetric data, for example, with the data from LiDAR survey, aerial LiDAR surveys. But to get all such kinds of the reports or data, you need to use purpose-built software for the bathymetric data processing. Usually we recommend HydraMagic because it's a kind of balance between complexity and power of processing package. It can generate almost everything what your customers may ask, and it is still not extremely complex to use. So actually, our standard course takes, as I remember, 4 hours. After 4 hours, you will be able to process data from single beam echo sounders and to generate at least standard output materials or reports. I will not dive deeper into data processing because it can take actually 1 hour or even more, just even the demonstration. Here is link for my live stream recording dedicated to the data processing. And one more topic, because it's an absolutely standard question. On the bathymetric surveys market is still dominated by unmanned and manned bots, of course, and will be dominated maybe for next dozens of years. So standard question is how your system accurate comparing with the standard methods. Answer is very simple. It is the same. It is the same because we use the same technological bricks. We use not the cheap Chinese fish finder as sensor. It's a survey grade high-end echo sounder. We use very high quality RTK receivers on the drones with a precision of few centimeters. And we use standard workflows for the data collection and for the data processing, absolutely standard. The only difference that platform for the sensor is not floating, it is flying at the 2 meters above the water surface. All other is the same. To exclude the factor of instability of the flying platform, we analyze the data from internal sensors, tilt sensors of the drone. We log angles of the sensor with every measurement. And we also may automatically reject when sensor was far from vertical orientation. Technically, and it is proven by multiple tests of our tests and tests of our customers, accuracy of the data is absolutely the same. I should say that, my opinion, I don't want to ignite discussion here, but drone flying at 2 meters above the water is more stable, and sensor with heavy housing is more stable comparing with the small unmanned surface vehicle, much more stable. That's all. We can start answering questions. First question is from Ismail. Can one use your system by attaching it to AUV and survey at a height of 12 meters. Unmanned underwater vehicle? Sorry, I don't understand your question.
Maybe it's UAV, just the spelling is, if it's
Maybe.
12 meters height.
Yeah, if it is about AUV, I think obviously our echo sounders are widely used for AUVs, but I don't understand about height of 12 meters.
Technically, you can use 12 meters long cable, but it should be not stable actually. Technically, it will work. And as I remember, Don, maybe you can help me. 12 meters cable is good for sensor.
As we are using RS-232, I
Yeah.
think 12 meter might be kind of maximum cable length for that interface, not degrading the speed of communication. But I think if you use only NMEA mode, then it is fine. But
Okay. So technically it will work. But we never tested the system with such long cable. As I remember, we tested it with the cable up to 5 meters, as I remember. It
I'm not
was
sure whether his question is about AUV or UAV, but obviously AUV, it is possible, but when he means height of 12 meter, does it mean AUV above the 12 meter above the bottom of the water kind of thing? I'm not very sure.
Yes, so yes, I'm still confusing. It is about flying drone or underwater drone. Okay, so both options are possible. Very simple answer. Next question, how is the depth data synchronized with the position data from the NMEA data format TXT? All the strings don't have time. So they are, I can show the data again. So the data here came in the groups. It's coordinates in 2 sentences, and in 1 sentence we have elevation. And we also log time till the milliseconds, and here are depth readings. So they are synchronized because in MEA file, what we log, data came in groups in the single file. Can an existing ECT 400 SBES unit can be used with the new high-speed fairing? You will need, we don't have ready design for it, for that. But anyway, you will need, so if the set was ordered from us or from one of our resellers, what you will need to do, you will need to send Echo Sounder back to us. We will replace housing, because with the old deliveries, weight of the housing was aligned for the maximum payload capacity of the drone. So we cannot just add high-speed fairing to it, because it will be overload for the drone. But technically it's possible. We will decide, we will implement that or not when we will understand the demand. So Peter, you can just drop me or to any known person on this page your request for that. What is the swash width of the Echologger? Echologger is a single beam system. It doesn't have swash. It has a footprint. You can easily calculate it from the beam angle, a bit trigonometry. I don't have a data here, but we have the data in our data sheets. Oh, and not here. So you can find information about beam angle on Echologger site, or in our web shop. We have a full technical specifications and bit trigonometry, and you can calculate the footprint diameter. Do you have a video of the UAV capture in the field? Yes, of course, we have dozens of videos. UAV bathymetry from our customer. Our video, maybe some, recording of our webinar, but you can find a lot of videos in our channel. It's quite old video.
Yes, and the channel is named SPH Engineering. Just type in YouTube and you will find our channel.
Yep. Next question is, can a drone be used if the river is very fast flowing with the rapid and strong currents? So if the speed of the current is less than 1.5 or 2 meters per second, you can use it with our high speed fairing. But also you can employ specific technique to fly lines aligned with flow direction. Here we have a case study from our customer. I will try to find it. Come on. Case studies. Coal mine. Chile. Here. They called that method sweep method, when survey lines are aligned with the survey lines. So when drone is flying along with flow direction and its speed more or less aligned with the flow speed, equal to the flow speed, it collects good data. You can plan the mission to have to pull sensor out from the water and start here again, or you can fly kind of zigzag mission. So when segment is aligned with the flow, you will get good data. In opposite direction, orientation of the water, vertical orientation will be too far from vertical, and data will be automatically rejected. So yes, you can use our system. The another issue, if water is fast flowing water is bringing some scrap, trees, something in the water. In such situation, answer is no, because risk to catch something in the water can be very high, or you need to have insurance. What about temperature will be associated to bottom or surface? Most probably temperature measured by sensor. Temperature will be for the sensor. It will be water temperature close to the surface, around, I don't know, 10-20 centimeters under the surface. Next question is, we would like to apply this technology on water dams. The idea is to understand or collect enough data to determine how much water is left in the dams to focus on solutions before dredging, drought. Also, which equipment would you recommend for this project? I would recommend to use simple single frequency echo sounder for the repeatable surveys. Standard basic system. If you expect that bottom has a lot of vegetation, I would recommend dual frequency echo sounder model called D24 to have clean data from the bottom, not from the vegetation. You can find, I think, a few case studies exactly for that scenario on our site. If you are interested, we have a lot of data. This one is very similar, actually. Next question. We are performing cable tracking measurements with magnetometers mounted on UAVs. We sometimes experience drifting in the RTK position during surveys. Is using a base station a better option for positioning with a single beam echo sounder system? You will have absolutely the same echo sound situation as you have with magnetometers, because we use to geotag echo sounder data. We use data stream coming from the drone built-in GNSS receiver. So if you are experiencing problems with configuration with magnetometer, you will have the same with echo sounder, of course. Normally, if you work far from the areas with the robust coverage of N-trip network providers, we recommend to have local base station, of course, RTK base station. So it will be much more stable and robust configuration. I hope that I answered your question, if I understand it right. Next question is from Mohammed. For hopping measurements, is there any limitations? Data points every 5 to 10 square meters apart. Actually, data density, it is what you should discuss with your customer. If they will be happy with measurement points in 5 or 10 meters from each other, that means that it is good. But sometimes customers require very dense data, few measurements per single square meters, for example. In such situations, you can use only multi-beam systems. But normally, what I see from our customers, from our direct customers, their customers are good, understand the situation good enough to be quite flexible when they discuss the data density, because data density will define at the end the cost of survey, of course. Next question is, what will be the optimal speed to fly with echo sounder and high ±2 meters above water? So flight height over the water defined by cable length. So normally in our configuration, we supply cable with length, as I remember, 2.4 meters. That means that, but it includes that part. So useful cable length will be approximately 2 and something meters. So you should fly at 2 meters approximately to have a sounder submerged to the water. Survey speed with high speed pairing can be up to 1.5 meters per second for very high accuracy of the data, and 0.8 meters per second for without a new high speed add-on. Next question is how to approach large setting point unknown liquid or sound transmissivity. So you, if I understand the situation right, you have to survey point, but you don't know sound speed in the liquid because it is not water, or almost not water, not water. What you can do, again, there is a special class of devices called sound velocity profilers. Sound velocity profiler. Maybe two most popular types of or models of devices. One is from UK Valleyport Swift SVP, this one. It's a great device with extremely high accuracy, and it is very simple to use. You need to attach rope here and drop it down to the water. Not drop, actually. Slowly put it down to the bottom and pull back, and it will record inside of the device the speed for the different depths. And you can get the file with measurements using Bluetooth interface, and it can be used by data processing software to recalculate time to the depth. And second option is Chinese manufacturer called Beijing Hydro Touch Marine Technology. I didn't have chance to test it, but what I heard, it's also quite good devices. Twice cheaper, of course, comparing with the European model. And also, what you can do, if you don't have sound velocity profiler, you can make measurement, say, in the point where you can somehow make manual measurement using measurement pole. So having data from Ecosounder, having ground truth data measured by trusted measurement pole, you can calculate sound speed in the water. Very simple. Next question is, what is the average spacing between flight lines in the professional survey grade use? Again, it is dictated by customer in requirements for the data density, but normally kind of common approach is the distance between survey lines for single beam echosounders is between 2 times to 5 times of the estimated average depth in survey area. So if you estimate the depth will be 10 meters, so the distance between lines 20 meters should be good enough in almost all cases. But again, it should be requirement from your customer. Next, what level of positional accuracy does SkyHub Ecosounder system deliver if using the DJI RTK base station? Can we expect the same level of accuracy? We geotag the data with the same precision as it came from the drone. So if DJI claims the precision up to a couple of centimeters, in case of if the base station is not too far, we log the data absolutely with the same accuracy. But of course, Ecosounder is hanging under the drone, right? We know position of the drone, but not the position of the sensor. So actually, if you use recommended speed, position of offset of the Ecosounder behind of drone will be approximately 30-50 centimeters maximum. You can account if you are surveying, say, pond or lake without current with the same speed, you can account that constant speed, constant shift in during the data processing. If you want to do that, actually, because normal requirements for the horizontal positioning of the data readings for bathymetry are not so high as, for example, for airborne lidars, right? So positioning accuracy plus minus 50 centimeters is good enough in majority of the cases. But what we are making now, one more simple device. Do you see me, guys?
Yes.
Yes. What is that? We will I hope shortly, we will start supply tracking camera, which will be attached to the Sky Hub, and it will track that orange ball attached to the cable in real time, making corrections for the horizontal and actually vertical position of the echo sounder. So we will have coordinates with the real precision of few centimeters, not for the drone, but for echo sounder. For me personally, it is over engineering and excess, but if some end customers for the data, for the bathymetric surveys will require such high level of precision, we will be able to deliver it. Normally you can think that precision of positioning in our system is around 30-50 centimeters for the data readings. How does survey planning software work? Is it a specific planning software? If yes, what parameters need to be set? So it is UGCS. With our system should be used UGCS, our flight planning software. It is not specific for the bathymetry. We have many thousands of customers who do all kinds of aerial works using drones, using our software. For bathymetric surveys, you may use standard planning tools like waypoints or survey grids. I can try to show something. For example, if you want to survey this area, I need to draw a survey area and specify distance between survey lines, say 5 meters, flight speed 0.5, and flight height 2 meters. That's all. So, flight planned. So parameters are flight altitude above the surface. It should, in most cases, it will be a bit less than 2 meters, defined by cable length. Speed defined by configuration. It is standard. It will be 0.8 meters per second. If you use high-speed fairing, it can be 1.5 meters per second or up to 2 meters per second. And distance between survey lines. And actually, that's all. Very simple. Next question. Do you use and implement GIS in your drone imagery that you capture? If yes, to what extent do you use it? Please explain in details. So, no, we don't supply GIS, Geographical Information System. You can integrate or you can use data which is or artifacts which are result of bathymetric surveys inside of GIS systems. You can import point clouds, you can import contour maps, you can import geotagged images, anything what you want. Next question is how much can a model like this cost? Please send a request and my sales team will answer. But you need to specify for what conditions to select model, because difference between single frequency and dual frequency echo sounders is approximately 2 times. Because dual frequency technically it's 2 echo sounders in the single casing. Next question, what happens when the ecosounder is entangled with the vegetation or underwater structures? Is the release implemented? Also absolutely standard question. We didn't implement any release mechanism or break because such simple but robust device will add approximately 1,000 euros to the price because it should be waterproof, it should be very robust with calibrated force for the detachment. If you really need it, you can reach our partner Tom Hiller from UK. He will be happy to provide you such device. My recommendation is to really estimate survey conditions, to check the presence of something dangerous in the water. If you want to lower the risks for such situations, you can use grasshopper mode. And anyway, my strong recommendation is to have insurance. Maybe you saw my post. Past year, we lost a drone in the water. It was not because of that reason. It was because our flight engineer forgot to close the lock on the drone arm before takeoff. So we lost drone in the water, and we get full compensation from insurance company. That's the only 100 safe option for the surveys using drones over the water. Next question is there any video camera or sensor, multispectral or hyperspectral used in these environments? Hector, I don't understand your question. For what purpose? You can drop me a message with more details. I will answer after webinar. Next question. Is this model suitable for water courses with a lot of tree trunks? In case of a lot of trees, tree trunks combined with a high speed of flow, no. My answer is no. But if it is some pond without current, you can make survey flying manually. It's also option. System logs the data when a ecosounder is in the water. Was it automatic flight or manual flight? Doesn't matter. Just put a ecosounder to the water. Or you can use grasshopper mode. In grasshopper mode, when sensor is going down to the water vertically, stays for a few seconds for measurement, and after that it pull it strictly up. Probability to catch something is very minimal. Actually, using the same approach as for that orange ball, it is very easy to make additional protector like a cone to minimize the risk to be catched almost to zero. So it can be used, but not in case of current. Next. I work in the water industry where all of our lagoon pits have a large amount of sediments, and sometimes sediment is compact and dense, but not as dense as true bottom of the pit. My question is, would your sensor be able to determine the difference between dense sediments and true bottom? If such sediments, physically, if speed of the sound in sediments is very different comparing with the true bottom, and 50 kilohertz sound will penetrate through that sediment, you will see the reflection from the true bottom. But practically, from our experience, until you will try, you will not know. Except simple situation. When you know, for example, you have bottom, rocky bottom and organic sediments, so answer will be definitely yes. But in such cases, in marginal cases, you need to try. So maybe you are from Canada or from United States. We can recommend partner or another customer who can do trial survey for you. Next question is, are there any tutorials or workflows available to help process ecosounder data using Bathymetric? Yes. At that slide, you can see link with recording of my live stream recording for the data processing using Bathymetric. Also, we should have ready electronic course. Let me check. In our academy. Let's check. Yes, we have a bathymetric data processing course here. But again, Bathymetric is not very complex software, so for me, it took a couple of weeks to be fully familiar with it. So time and money wise, it is better to take the course or at least to watch our recordings. And last question. Can you enter an RTK survey at base station coordinate as the starting point of survey? If drone is in RTK mode, you use RTK base station and you transmit corrections to the drone using standard tools, and the drone is in RTK mode, you will get precise coordinates right in the data. If you will if drone will be in PPK mode, you can post-process data, refining coordinates during data processing. That's also option, but only with one very important point. DJI drones work in PPK mode only with DJI payloads, unfortunately, because they log RINEX data, full data for the PPK processing on the in the memory of DJI payload. So if you want to use DJI drone and PPK mode, you need to have additional PPK receiver on the drone. That's also pretty standard configuration. I maybe can show you photo. So in such configurations, we use maybe you can see small additional antenna on top of the drone here. It is Reach M2 receiver, MLEAD Reach M2. So in that configuration, you can do post-processing for coordinates. Whew. It seems we're done.
Quite a lot of questions, though.
Yes, thank you. Thank you for participation and for the questions.
Yeah, I would like to remind only one thing before we end, that we will, by the end of this week, share the presentation, including the recording for all of you via mail, and also there will be a contact links for to Alexa and Dawn. So whenever you have questions, please do not hesitate to reach us. So once again, thank you, and have a good rest of the day or evening.
See you.